with that in mind, okay, now most of you have been practicing organic naming up till now. Okay, you've got a couple of steps when you start to name an organic chemical. Most of you start by counting your longest carbon chain. You've decided how those carbons are stuck together, and from that you'd select ane, ene, or ine. Some of you have gotten pretty good at numbering carbons. Some of you have gone as far as putting chloro, bromo, iodo, all of those things onto organic molecules. If you have not, don't stress. I'm going to revise some of that today, but I do need to forge forward with some of the newer work. Now, do you guys know what a homologous series is? Okay, I'm seeing some nods and some like, Okay, now a homologous series, if you want the textbook definition of it, and it is in your textbook, so you don't have to scribble it down, it's a family of compounds which all share the same functional group. Now, up to now, your functional groups have included alkyl side chains like methyl, ethyl, maybe even propyl. Chloro, bromo, iodo, anything that can go in place of a hydrogen is considered a functional group. Even double bonds and triple bonds are considered functional groups. It's anything which makes your molecule special or separate from the others. Now, what we're going to start doing now is we're going to start introducing oxygen. Now, the reason that oxygen is so weird and interesting is because oxygen can make more than one bond. Oxygen can make two bonds, and that's pretty important to note. Everything that you've done up till now only has a single bond. A methyl only has one place to bond. Hydrogen, chlorine, bromine, iodine, all of these things only have one place to bond, but oxygen has two. So the first and probably the simplest one, pretty much everyone's heard of before, and these are the alcohols. Now, there's a difference between a functional group and a homologous series. So the alcohols, this is the name of, I don't know if that's actually even on the screen. Let me just shift it around a little bit. Okay. All right, so alcohols are the homologous series. That is the family of compounds. What identifies them is this OH, and that's called your hydroxyl group. Let me just make that in a slightly more visible color. Let's make it nice and fat. Okay. So the alcohols have all got this OH group somewhere over there. I'd like you to circle it as well as we go. If you see that on your molecule on its own joined to a carbon, that means that you're dealing with an alcohol. So every alcohol has got this in common. They all share this functional group, this hydroxyl group. So hydroxyl, whoops, I shouldn't be rubbing it out. Okay, so hydroxyl group is something that identifies every single one of these. Okay, now, there's something in common with all of them as well. As soon as something is in a homologous series, it takes on some sort of name. So everything with a chlorine in, what do I add to the front of that? Chloro. So if I have a fluorine on something, I put on fluoro. Iodo, bromo, methyl, ethyl, propyl, all of these things get added to my name to show me that that thing is on my molecule. So the way that I do that for alcohols is slightly different. The reason that I've kept these separate from all the others is because an alcohol actually changes the end of your word. And that's pretty important to note. Now, this shouldn't be unfamiliar to you before. You've changed the end of a word before. When I had a double bond, how did I change the end of a name? I put an "ene" to indicate that there was a double bond. Now, this changes even after that. Now, it says that the names of alcohols end in "ol." Now that "ol" actually takes the place of the "e" at the end of all of your names. So let me give you some examples. If you had methane, which is one carbon, 4 hydrogens, and you put an OH on there, what would I call that? So it's methane, except you chop off the "e" at the end, and that becomes methanol. So methanol becomes your name. So this compound over here, they've started naming it. And what we're going to do is we're going to do it as well. So I'm going to highlight this with this really weird laser pointer thing. So how many carbons have I got there? What have I got? Okay, so I've got 4 there. So there's 1, 2, 3, 4 carbons over there, all in a single row. But I noticed that there's a hydroxide over there. So how do I start my naming? It's exactly the same as the others. Count your carbons, that gets me bute. So 1, 2, 3, 4 gets me bute. How are those carbons stuck together? They are single bonds. So this is butane. So even when you're starting to name these, you'll get better and better and better at these. So I'm going to write down butane, and I'm going to show you what I mean. So there's butane. So butane is the starting of this name. But now, once I've indicated that there is a hydroxyl on it, I need to change the end of this. But you know that this is not called butaniol. What you do is you actually chop off the E to make space for an ol. So it becomes butanol. So you chop off that E to make space. And you're going to see that same pattern. Anytime there's an oxygen on, you chop off the E to make space for something else. So when I've got an ol, that means that I've got a hydroxyl somewhere on here. Is everyone relatively happy with that idea? Anytime you've got an OH, that means that I change the end of my molecule to ol. So let me run you down the pattern. So 1 carbon, methanol. 2 carbons, ethanol. Propanol, butanol, pentanol, hexanol. Anytime you've got something, you just add ol to the end, and that identifies what you've got. Is everyone relatively happy with that? Okay, now I'm going to do something really annoying. I'm going to ask you to work. Okay, I know it's after school and you guys are tired, but let's try this out. Okay, now there's 3 different categories of alcohols, but before I get into that, I want to show you how they got to the names there. And I want you to sit next to somebody or confer with the person behind you how they got to the names that they did. Okay, so the first one on the left there, right, can you see this one over there underneath primary? How many carbons do you see in the longest possible chain there? I've got 1 over there, 2 carbons. So I'll start my naming, okay? So let's grab a pen there. So I say that that is eth. Okay, great. How are they bonded together? Single bonded. So what, is it an, ene, or ein? An. Now I'm not going to put on the E because I see that there is an ol somewhere there. So I see an ol over there. Luckily for us, it can't be in any other position, so I just call this ethanol. Okay, right, ethanol is normal drinking alcohol. This is the stuff that people have talked about as alcohol. Okay, I can see some of you are smiling like, yeah, ethanol. Okay, so ethanol is the stuff that gets you drunk. Okay, this is the stuff in wine and beer, whiskey, spirits. Okay, so now you know exactly what is making you drunk and hungover the next morning. A lot of you seem to be laughing out of experience, and that worries me slightly. Okay, so let's move on to this next one. This next one's got a slight complication to it. Can anyone see the problem here? What is that problem? Okay, so there's 3 carbons, so let's count them. I've got 1 carbon, 2 carbons, 3 carbons. That gets me my prefix of prop. Sorry? They are single bonded to each other, so that means prop, an. Okay, so that indicates that they are single bonded. But now here's the problem. The ol, the hydroxyl, can be on any one of those carbons. It can be on the first carbon, on the second carbon, or on the third carbon. Now anytime you've got something which can move up and down your chain, you need to give that something a living address. So in this case, we need to start numbering carbons, and that shouldn't be something that's unfamiliar to you. And just like for ene or ein, we need to give that ol a living address. So over here, I've got propan, and on the second carbon, if you want to number those carbons, we can. Okay, so I've got carbon number 1, carbon number 2, carbon number 3. So on the second carbon, I've got an ol. And just a reminder that anytime you put a number next to a letter, what do I need to use to separate the two? I need to use a dash to separate words from numbers, always. So as you can see, they've named this as prop for 3 carbons, and because those 3 carbons are single bonded to each other. And on the second carbon, I will find an ol. Now, if you drink this alcohol, you will die. Okay, this alcohol is the alcohol that you use to clean whiteboards with. Doesn't smell particularly appealing, and basically it just liquefies your liver, makes you blind, and you die. They are both alcohols. You drink one, you get merry, a little bit more talkative and oversharing. The other one, unfortunately, you will share pieces of your liver. Okay, so not a good idea. If a barrel is marked in alcohol, even if it is marked as ethanol, it's not safe to drink. Industrial ethanol, okay, a lot of people have died drinking industrial ethanol because they know that people like to get drunk, so they mark these alcohols by putting some methanol in, which is the same stuff that you find in meths. Okay, meth is not a good idea to drink because the ethanol, yes, will get you drunk. The methanol in it will get you dead. Okay, all right, and this very last one. Okay, I'm pretty sure that you guys can name this, and I want you to try this out for yourselves. How do they name this? I'm just going to do the little spotlight thingy again. So in the longest carbon chain, I've got 1, 2, 3 carbons over there. All right, that's my longest carbon chain. In fact, let me highlight that. My longest carbon chain, you'll have to excuse me, I'm a little bit shaky. There's a lot of coffee in the system. Okay, so there's 1, 2, 3 carbons. Name my backbone for me. 1, 2, 3 gets me prop. Okay? How are they bonded? Single bonded. So this was propane. But I did something to it. There are 2 somethings which I did to it. Okay? So there is a CH3. What do I know as a CH3? That looks like it's methane, but it's a side chain. Methane becomes methyl. Nicely done. So that is a methyl. Anytime you see a carbon side chain, okay, you're going to see the grade 1 writing now. Okay, so that is a methyl. And I know that there is also, somewhere down here, that is an ol. Okay, so I've got a methyl and I've got an ol. Now here's where you've got to get really clever. The things which only make one bond, like a methyl, or a chloro, a bromo, an iodo. All of those you will add to the front of a name. So you'll put chloro, iodo, bromo, methyl onto the front. But as soon as there's oxygen that can make 2 bonds, you put it at the end. A lot of people get confused with this. Okay, anything which can make multiple bonds must go at the end. That even applies to your alkenes and alkynes. Look at where you change things. You change the end of the name. So, which do I put in front? Methyl or ol? Methyl. Where does the methyl live? On the second carbon, right? And also, where does the ol live? On the second carbon. So you can see there, 2-methyl propane -2-ol. All of those dashes are important. And when you say this name back to yourself, I want you to practice saying these dashes. Question? Okay, there is another way to name alcohols. Just like you name alkenes. I mean, I've got options like this. You can say prop 1E, or you can say 1-propene. Those are 2 options which your IEB will give you marks for. However, you can do the same thing with alcohols. You can call something propan-1-ol, or you can call it 1-propanol. Now, the reason that I prefer the one where you say propan-1-ol is because you put the number next to what it's addressing. And that way, you're always naming things in the same way. Otherwise, I've got a separate system for alkenes and alkynes, one for fluoro and bromo and iodo, and then another one for alkenes, then another one for alcohols. I'd rather name everything exactly the same way. Okay. Now, there's a little bit of reading underneath there, which gives you a little bit of background into what alcohols are used for. Most of these organic molecules that I'm going to talk to you about this afternoon have got an industrial use, and you are expected to know at least 1 or 2 of them. Alcohols, specifically ethanol, is used obviously in spirits and beers and wines. It is in your textbook, it says there. Here's the other big use for ethanol coming from 2015. Ethanol can be burnt inside a car that burns petrol. You can replace petrol with ethanol. It's called biofuel. Because you can make alcohol from pretty much any plant matter, you let the stuff rot, and it turns into petrol, basically. I mean, that's what wine is. It's just rotten grapes. If you distill that wine into pure alcohol, into pure ethanol, you can put it into a car and the car will run. So that's a biofuel. Other uses for alcohols, they're very good cleaning agents. That's why we've got meths in the home. Unless you're a hobo and you filter it through bread and you drink it and you go blind, that is what you use meths for. You do not drink the stuff. Okay, now, this is a point at which I'm going to give you a little bit of time to practice on your own. Now, I want to give you examples which are not in your textbook, but I'm going to give you a little bit of time to draw them and to name them. They're nice and big, so you should be able to see them on the board. Okay, so I've got a couple of examples on the board there behind me. All of them are slightly different. I want you to take some time and try to name these. Spend a little bit of time discussing with your friends. If you're watching this recording afterwards, I actually want you to practice this from fresh, even if you're re-watching. Okay, so I've just made the pictures a little bit smaller so that I can start scribbling all over them. The first one, I'm pretty sure most of you have managed to name properly, and that shouldn't be much of an issue with you. If you start taking a look at this molecule, I've got 2 carbons. Right, how they join together is single bond, so I get the prefix of ethane. Okay, so let's just get a nice color to work in. Okay, so ethane. Right, now I see that there is an ol. There it is. I've got this hydroxyl. So where do I put ol? On the front or on the back of the name? It goes on the end, because anything which can make more than one bond, it's going to go onto the back. I've replaced the E of ethane, and it becomes ethanol. Okay, that wasn't too hard. Ethanol. Why have I not put numbering in there? It doesn't matter which way I number this, it's always going to be on the first carbon. Now, if I wanted to, I could also call this ethan-1-ol. If you want to always put numbers in, that's okay. That's not a problem. Okay. If something is on the first carbon and there's only one of them, it's not necessary to put numbers in, it's assumed. Okay, what about this next one? On the top right, I've got a molecule which is called a skeletal structure. Now, the way that I figure these out is actually by putting them back in the carbons. So that's exactly what I'm going to do. I'm going to redraw the carbons because it's kind of confusing to look at just lines. And the rule here is at the ends and at the bends, you have a carbon. So that helps me count. So I've got 1 carbon, 2 carbons, 3 carbons, with all of the hydrogens that they need. So how many carbons you got there? 3 carbons. Okay, so 3 carbons single bonded gets me propane. Okay, so I've got propane, but I'm not going to put an E on because there is a ol at the end. Now, because this ol could be in multiple positions, I would suggest that you give it a living address. It could be on the middle carbon as well. So I would suggest that you put in propan-1-ol. Okay, you could put in 1-propanol if you want to, or just propanol. Okay, but because there's only one possible place for it to be, no, there isn't, sorry, my correction. It can be in multiple places. You can get propan-2-ol, where the OH is moved to the middle carbon. Now this one down at the bottom is particularly nasty, bottom left. Okay, it's horrible. I've drawn it all back to front, but this is what organic molecules actually do in real life. They twist. Single bonds can rotate, and molecules take on really weird shapes. So when I start taking a look at this, how many carbons do you count in the longest chain? So there's 1, 2, 3, 4. Most of you managed to get that. So that gets us a prefix of bute. Okay. Single bonded, again, butane. But here's the problem. It's got an ol in 2 places. That makes this molecule a diol. Not only that, now I need to start numbering the carbon atoms. Now, do I start numbering from the left or from the right of the molecule? What do you think? Okay, so I'm hearing some people from the left or some people from the right. How do I tell? Let's put down both numbering schemes and let's see which one's correct. So if I start numbering from the left, that would be 1, 2, 3, 4. Start numbering from the right, I would have 1, 2, 3, 4. Now the way that I choose is I start to see where everything is substituting hydrogen. So I see something replacing hydrogen if I choose the blue numbering on carbon number 2 and carbon number 4. Add up 2 plus 4 for me, 6. Add up 1 plus 3 for me, 4. 4 is much better than 6 because you want all of your numbers to be as low as possible. So the red numbering scheme is the correct numbering scheme to choose in this case. Let's finish off our naming. Now, I need to give each one of those ols a living address. So how do you put multiple numbers? I put dash 1, 3 dash. So it'll be butan-1 1,3 diol. If you managed to get that, congrats, it was a really, really tough one. Very, very difficult molecule to name. Okay, now for this last molecule, there's a particular problem which some of you might not have studied yet. I've got 6 carbon atoms, and they are in a ring. So I've got 1, 2, 3, 4, 5, 6 carbon atoms, if you draw them all in. Remember, the rule is at the ends and at the bends. So there's 6 bends over there. If you want to, and especially while you're first getting used to this, actually write in the carbon atoms. If you want to, you can write in the hydrogen atoms as well. But this tells me that there are 6 carbon atoms over there. Okay, so that gets me a prefix, correct? Almost. There are 6 carbon atoms, but they are now arranged in a circle, or they are cyclic. So what does it mean for our backbone's name? Cyclo. So it's cyclohex. That means in a circle I will find 6 carbon atoms. They are single bonded to one another, so that means cyclohexane. And now the really cool thing about this is it doesn't matter how I name this, but this is always going to be carbon number 1 because I want it as close to the ol as possible. So cyclohex, so here we go, cyclohex, and you can put in -1, -ol if you want to. If you left out the 1, that was also okay. Is everyone okay with what we've done so far? No problems. Yes? Cyclohexanol is perfectly acceptable. If you leave out numbering, it's assumed that it's on the first or only carbon that it can be on. Okay, so cyclohexanol is perfectly acceptable here. All right, is everyone still with me? I can see that people's attention going. Okay, right, now let me just introduce the last 2 families of compounds. We'll take a little bit of a rest and we'll start naming some extra bits and pieces. Bit of a blank page for any practice, or it doesn't seem that there are any. The next ones are really, really important because they also have oxygen in them. Right, now, this particular homologous series, they're called carboxylic acids. It's because they have something called a carboxyl group. Now, a carboxyl group is just one carbon which is lucky enough to be bonded to 2 oxygens at the same time. So this carbon's kind of greedy. This carbon at the end here, right, is bonded to 2 oxygens, and that is an example of a carboxyl. Now, since these compounds are acidic, we call them carboxylic acids. Now, pretty much all of you has consumed a carboxylic acid. If you haven't eaten any food. Okay, pretty much all of your food contains carboxylic acids in some form. Anything which has got a sour taste to it, including fizzy drinks, have got carboxylic acids inside. Carboxylic acids are the basis for fatty acids, and every single one of the fat molecules that you eat has got a fatty acid which ends in a carboxyl. So they are called carboxylic acids. Now, whereas in alcohols we name the end of the compound as ol, the end of these molecules is called oic acid. Okay, so let me just give you some examples. Let me just see if you can get it rolling off the tongue. So if you had a 1-carbon carboxylic acid, what would it be called? So 1 carbon is meth. So methanoic acid. So methanoic acid. 2 carbons, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid. You can get, anything oic acid. That just means that it ends in this. Now, I just say this with a warning. This carbon that's involved in the carboxyl is actually part of your backbone. Please don't leave it out when you name these. Okay, so we're going to come up with a couple of examples, and I'm going to see if you manage to name these relatively easily. But for instance, I'm just going to draw an example underneath here. So this is a particularly badly named carboxylic acid. This is quite a common one that people get wrong. So I'm just going to draw this example, and I want you to see if you can name this. Now, you're going to be forced to understand which one of these is more important, the branch or the oxygen. Now here's your rule. Anything which changes the end of a name is more important. So that means oxygens, double bonds, triple bonds are more important when you're starting to number. Okay, so has anyone got a suggested name for this really badly drawn molecule? Yeah? You've only left off one thing. Getting there. Okay, so let's count our carbons. Okay, so the longest possible carbon chain, and I'm going to do this in the most annoying possible way. I'm going to count around corners so that you get used to it. So my longest possible carbon chain, doesn't matter which carbon chain I follow, is 3 carbon atoms. Now, here's the really tricky part. That carbon with the 2 oxygens is both the functional group, but it's included in the parent chain, included in the backbone. So I see 3 carbons. Let's start to name this. Prop or prop. Okay? Okay, so my stylus is busy giving up there. Okay, so prop and, because they are single bonded, and because there is a carbon at the end with a double bonded oxygen and a OH on it, this is propanoic acid. Now, here's the problem with what I've done here, apart from the fact that I haven't left enough space for myself. So propanoic acid is the basic molecule, but there's still something on the side chain. It's a 1 carbon branch. What do I call 1 carbon branch? It's a methyl. Okay, so where does the methyl live? Does it live on the first carbon? And if so, where is the first carbon? If I've named something propanoic acid, I've already decided the first carbon. The first carbon will always be the one which has got the oic part on it. The carboxyl becomes carbon number 1. You don't number carboxylic acids. You always assume that they exist at the end of a chain and they are always on the first. Now, there's nothing wrong with putting in a number, and I'm pretty sure that the IB would mark you correctly, but very, very seldom do you see these things numbered. So I assume that it's propan-1 oic acid all the time. Okay, so where does the methyl live? On the second carbon. So if I write this in a slightly more organized fashion, what would it be in its full glory? Yeah, let's write this from beginning. Let's just select something. Can you guys see green on this? No, you can't really. Need a dark color. Okay, so it'll be 2 methyl propanoic acid, all one word, except the acid part. That's a separate word. Now, notice how the methyl and the propanoic stick together as one word. That's because all the carbons are connected. The minute you disconnect carbons, you disconnect words. Question, Tyron?
Do carboxylic acids have to have a hydroxyl ion, an hydroxyl and
Oh, good question. Okay, do carboxylic acids have to have both the double bonded oxygen and the OH? Yes, they do. On the same carbon. Now, these, even though they've got an OH, are no longer called alcohols. Because they've got that particular combination, that functional group, they are carboxylic acids and no longer alcohols. So that OH there is no longer hydroxyl. It's part of a carboxyl. Okay, so this thing which I circled a little bit earlier, so just take a look on the screen. This thing, that was really weird. All right, that thing over there, that is a carboxyl. The entire thing, carbon, oxygen, oxygen, hydrogen, is a carboxyl group. Okay, is everyone relatively happy with this? Want to try some for yourself? These are very simple ones. Okay, so try these out. I'm going to give you a minute or two to name them, and we're going to come back to this. Okay, most of you have managed to figure out that the one is not drawn entirely correctly. Okay, now that one on the left needs to have a carbon drawn in there. Okay, because I've mixed up my drawing styles. Okay, because it's got skeletal with normal drawing style, but the drawing program that I use starts off in skeletal, and I've got to put in carbons myself. And I forgot one. Okay, so when we start to name these, really not too difficult. I think most of you will manage to to get these for yourselves. Can I have some suggestions on the first one's name? Does everyone agree? Butanoic acid? How did you get there, Tyron? So I count the longest carbon chain. So let's actually circle it, and this is good practice to do anyway. Longest carbon chain. Really badly circled. Okay? Then what? Okay, so I mean, it's just good practice to start numbering your carbons. So carbon number 1, carbon number 2, 3, 4, and then? This is the giveaway sign. Okay, so let's make that really ugly purple color. Okay, here is your giveaway that you are dealing. I don't know what it looks like on the screen. It doesn't even look like purple. But there is your giveaway that this is a carboxylic acid. You have got a carboxyl, a C with a double bonded O and a hydroxide in combination. That's the magic combination that makes this an oic acid. So let's put it all together. So 1, 2, 3, 4 carbon atoms gets me the prefix of but. The fact that those 4 carbons are single bonded gets me an. Right, and then? How do I end this off if it's a carboxylic acid? Oic acid. Okay, so that's not too tough. I hope the people managed to see this. 4 carbons is a carboxylic acid, is butanoic acid. The stuff smells terrible. It smells like rotten milk. Rotten milk does have propanoic acid in it. And this is one of the reasons that it tastes sour and curdles. Carboxylic acids are pretty much everywhere. This other carboxylic acid, pretty much every one of you has consumed. Okay. Right, what is its chemical name? Let's name it. 1, 2 carbons gets me eth. They are single bonded, so it's ethan. Oic acid. I think I'm running out of battery there. Okay, ethan, oic. I didn't mean to write all over the screen. Come on. Okay, ethanoic acid. Okay, it has a common name. Vinegar. Okay, vinegar has the chemical formula of ethanoic acid. So, a pretty weird way to ask for some vinegar with your chips. Okay, but ethanoic acid, 1, 2 carbons, gets me eth. They are single bonded, and notice how I'm repeating the same pattern again and again and again for naming. Always start with the number of carbons. Always see how they're bonded, then see what else is attached. Is everyone happy with this? Okay, onwards to the next and most torturous one. You'll notice that I'm skipping. Okay, ketones and aldehydes are no longer in your metric syllabus. All right, take a pencil, scratch them out. They are not examinable. Okay, and I have it on good authority from your teacher that you will not be testing them. Okay, so they won't just pop into your exam out of nowhere. Okay, now, this next family of compounds, this next homologous series, these are called esters. Now, this has nothing to do with anyone named Esther, obviously, but you'll notice that they've got something in common with carboxylic acids. What is it? They've got the double bonded oxygen, but how are they different? They're missing a hydrogen. They are actually linked up between 2 carbons. If you see carbon linked with 2 oxygens, it might be a carboxylic acid, it might be an ester. If that second oxygen is on a hydrogen, it's a carboxylic acid because acids have got hydrogen, and this is how I remember. I do not see any hydrogens in that thing that I've circled over there, right? So when you're taking a look at this, this looks a lot like a carboxylic acid, but with one very important difference. The carbon is linked up with a double bonded oxygen over there, right? It's linked up with a single bonded oxygen, but that oxygen is actually linked up with another carbon atom on the other side. And that's the really important distinction to make. Okay, now, how do I end these compounds' names? Now, here's the problem. Esters have got 2 carbon chains. So that means that you need to have 2 parts to your words. Now, the main part, the part that has got this on, ends in O8. Okay, so instead of oic, it becomes O8. So let's name our first one. Okay, now, it might seem a little bit confusing on how we're going to do this, but we're going to name this molecule over here in some various pieces. Okay, now you need to identify which carbon chain has got the ester functional group over there. And there it is. I'd like you to circle it, please, because that's where you start to decide your naming. Okay, so the one on the right, I can identify that that was the parent molecule, and that's where I should start naming my molecule. How many carbons do I have inside that molecule? There is 1. So what is the appropriate prefix for 1 carbon? Okay, so it's meth. Unfortunately, you don't have a possibility for a double bond, so it's methane, always. You can't get methene or methine. So it's methane. What else? How do I end this? So it's methane, O8. That's what identifies this as an ester. That O8 part at the end, that identifies this as an ester. Okay, but there's something hanging on to the side. What is it? There's a single carbon branch off there. Right, so what is it? Most of you have managed to figure it out. I've got a single carbon branch. What do I always call a single carbon branch? Methyl. But I'm going to do something very different. Where should I put it? Where do I always put a methyl? At the front or the back? At the front. But now you don't connect it with your original word. Why not? There's an oxygen in the middle. The reason that you don't write them together is because they are not connected together. There's an oxygen in the way. So this is methyl methanoate. There's an awful lot of meth in this picture. Okay. All right, so methyl methanoate. Slightly worrying. Okay, so methyl methanoate. There must be a space between those words. Perhaps my spacing is not big enough, but maybe highlight the space and say this space must be here. If it isn't, line through your name. Okay, now what I'm going to do is I'm just going to let you breathe for a little minute. I just need to speak to one of my matrics. Right, so we've got this example of an ester in front of us, and one of the reasons that we have to learn about esters or know about esters is because esters make up pretty much every flavor and smell that you associate with food and perfumes. Okay, they tend, especially the simpler, smaller esters, tend to have a very fruity smell. Now, anytime you're eating like a flavored sweet that's like lemon flavored, basically it's just a chemical cocktail which is designed to lie to your nose and your mouth. Esters give you the indication that you're eating something which actually had something to do with fruit. I'm pretty sure that that fruit pastille or that chewy sweet that you're eating at the moment has never even been in the same room as fruit. So, these esters have got a very fruity smell. They're very often used in perfumes as well. Okay, now we've got to name this monster. And what I said to you before we took a short break is that I wanted you, and this is one of those exceptions, to make an adjustment to your first rule of naming. Your first rule of naming says find the longest carbon chain. But only if that longest carbon chain includes the thing which defines your homologous series. So which part of this molecule, if I split it into two halves with, that oxygen, there's a splitting point. So if I was to split this molecule in half, there's a splitting point down the middle. Which half, the left or the right, defines this as an ester? Definitely the right. The giveaway, the thing which identifies it, is this part. That identifies this as an ester. So that's where I'm going to start my naming. Okay, so now I've identified that this part is the part which clues me up that this might be an ester. Let's name that part. So what is it? So 1, 2 carbons. Remember that there are 2 carbons. Please include this carbon in your naming. So 1, 2 carbons, both of those. If I name that, what should it be? Come on, 2 carbons gets me eth. It's too early to go to sleep. They are single bonded. An. Right, because this is an ester, I know that it's O8. Okay. Now what is clinging onto the ethanoate by an oxygen between them? I've got something over there which is clinging on, this 3-carbon clinger on. Okay? What is it? If it's a 3-carbon long side chain, what is it? Propyl. Now where should I put it? Before or after ethanoate? Before. And what else do I need to take care of? I need to leave a gap. So 2 words, propyl ethanoate. That is your full chemical name for this particular ester. And I'm not sure if it's possible, but you guys were actually meant to do a prac to produce this particular one. This smells like, you know, those really nice smelling board markers that you just want to sniff all the time. Maybe it's just me. Okay, so propyl ethanoate smells, I don't know, it just smells like cleaning products, and it's, you know, it's really nice to sniff. Okay, it will not get you high, unfortunately. Okay, it just gives you the sensation that you're sniffing cleaning products. And yes, you are, and that's probably not a very good idea. Okay, so propyl ethanoate you can make. Now, it's actually really not that difficult to make. This is definitely one of those shake and bake recipes where you can just mix 2 things, warm them up slightly in some warm water, and you get this beautiful smell out. Probably the easiest chemical compounds to make in terms of organic chemistry. We're just going to pause for a second. Now, when you make an ester, the thing which joins them is oxygen. And that actually gives us a clue as to where they come from. Now, esters very often look like carboxylic acids because they come from carboxylic acids. Which carboxylic acid do you think made this particular ester? Ethanoic acid. Absolutely. If I highlight it, and let's actually do that. Let's just take a look at it. So on the right-hand side over there, how would I make this back into ethanoic acid, this part? What do you think? I would chop off at the oxygen. Let's actually do it. Let's draw it. So, I mean, I'm going to take apart propyl ethanoate into its pieces, and I'm going to show you how they fit back together. Okay, so propyl ethanoate. So I've got my 2 carbon atoms still. So it's still ethan, but now I'm going to make it back into ethanoic acid. Right, so instead of joining the oxygen onto another carbon chain, that's the acid that propanoate came from. It's quite easy to see what happened in the process. Where do you suppose I would get a propyl from? A propyl with an oxygen on it? What do you think might be a good candidate for that? Think back about 20, 30 minutes. Propanol. If you had 3 carbons, single bonded, like they are in the picture. Okay, let's just fill up with hydrogens. You're going to get very sick of hydrogens if you aren't already. Okay, so the way to put an oxygen onto a propyl over here is to put that in. So what is that molecule? 1, 2, 3, prop, single bond, and because it's got an OH, it's propanol. Nice. Not too tough. Okay, so what I'm going to do is I'm just going to make a bit of space and I'm going to name these. Can you guys actually see what I've written there? Or is it getting a little bit soft? Let me choose a darker color. Okay, so now let's just name the things that made propyl ethanoate. Yeah, what's up? Okay, so now if I name the alcohol on the left, that was propanol. And on the right, we had ethanoic acid. Now, can anyone see the problem here? If I put those two together, they don't just click together. There's something in the way. There's too many atoms. Which atoms are in the way if I click those two together? So in the final product, I've only got one oxygen joining them. I see one major, major problem here. There's two H's and an O in the way. So what do you suppose happens if you start thinking about this? That's what gets out of the way. So when you put propanol and ethanoic acid together, The other product, when you make this ester, is plus H2O. You take water out and it allows the oxygen to make that link between the two of them. Sorry? If you heat it up, it drives off the water. Now, there are ways to speed this up. There are chemicals which you can add which speed up reactions. Do you know what those are called? Catalysts. So now the catalyst that I would use if I wanted to get rid of water is something which really likes water, and that's H2SO4. The catalyst for making esters is H2SO4. So I just want to do one more example with esters because I can see a lot of you getting really tired. We're probably going to end off the lesson fairly soon. I just want to make sure that people are completely okay with how to draw esters and how to predict products of esters. Okay, so let's go for this. I'm going to give you an example, but I'm going to show you the alcohol and the acid, and I want you to draw and name the ester. So I want you to go in reverse to what we've done now. So what I'm going to do is I'm going to draw an alcohol. Whenever I draw one of these chains, people are hoping I'll stop the carbon chain, because each carbon comes along with a couple of hydrogens, and that makes drawing really long. Okay, so just for naming practice, what is this alcohol called? 1, 2, 3, 4 carbons, all single bonded. This is butanol. Very nice. So now I've got butanol. Now I'm going to draw this in a horrible and misleading way. I'm going to give you the carboxylic acid, but I'm not going to draw it in a nice, easy way to face each other. I've got 3 carbons inside a carboxylic acid. What would I call this? It's propanoic acid. So it's propanoic acid. So this is propanoic acid. So propanoic acid. I want to know what happens when you mix these with some sulfuric acid and heat them up. I would like to know the structure and the name of the ester which you make. I'm going to leave you with that for a little bit, and I'm going to let you work on it. I want you to argue with the people around you, fight over this, draw it, and I want some names. Okay, so if I want to indicate that there's sulfuric acid going into this reaction, H2SO4, which is my catalyst. Okay, and how do I indicate that something has been heated? Little triangle. Okay, sometimes you'll see a top or bottom. I don't really mind as long as it's drawn around the arrow. You can show me how it got from one state to another. Okay, now, I don't think I've got enough space to draw this, so let's just make things a little bit smaller. It's getting so small you can't even see it anymore. But how do I draw these as a product together? What do you think? Now, I was really annoying in the way that I drew these because they need to be facing each other to connect. That's the problem. The oxygens were both on the same side, so it's really tough. Which one do you think I should swap around? Doesn't actually matter. You want to swap around the butanol? Let's do that. It doesn't really matter. So what I'm going to do is I'm going to show you what comes out. So if I swapped around the butanol, doesn't really matter. All these organic molecules can rotate. They don't mind which way around they're drawn. That's not a problem. Okay, so I'm going to draw the propanoic acid exactly the same way. Okay, so 1, 2, oh, that's horrible. I'm so sorry, guys. Less coffee next time. Okay, so 1, 2, 3. There's my propanoic acid. But now propanoic acid is not going to be propanoic acid anymore, because the oxygen now doesn't have an H anymore. So I've got my propanoate, which is now my ester. I've made it into an ester, which is exactly what it should be. So this is propanoate. But attached to my propanoate is the butanol, which I've now rotated. Can everyone see what I've done there? I've swapped the butanol around, and I've lost 2 hydrogens and 1 oxygen, which is exactly what I wanted to do. 2 hydrogens and 1 oxygen, better known as H2O. You must show your other products. And this reaction itself, the combination of an alcohol with a carboxylic acid, I mean, scientists aren't really the most creative people. This is called esterification. Because guess what? You're making an ester. So it's esterification if you want to give it a bit of a title. Okay, so esterification is the name of this thing, even though it's written like a grade 1. Yes, questions? Let's take some. Right, so now that we've done esterification, we've got to name our product. Okay, so let's name this thing. Again, I'm going to make a little bit of space. So I've got to name the organic product, and this one's a little bit of a pain because I've done the same trick again. Which one makes this an ester, the left part or the right part? So if we were to divide this into 2 pieces, so if I divide it into 2 pieces, left or right? The left part makes this an ester, so that's the part that I'll start naming first. So what do I call that? 3 carbons in an ester form? 3 carbons is always? Okay, so prop. Single bonded, propan, O8. So propanoic becomes propanoate when it goes into an ester. So that's the left-hand part of this, which is named. But now, when I take a look at the right-hand part of this, this is no longer butanol. It's just a carbon chain which is 4 carbons long. What do I call it? If it's 4 carbon chains, 1, 2, 3, 4 is but. So you don't have to say butanol, it's just butyl. Okay, so it's just butyl. So this is butyl propanoate. Okay, now, somebody was asking me, how do I do the condensed structural formula for this? And it really is a pain. I think it was you, Tyron. Okay. Now, the condensed structural formulae for these can get a little bit complicated. But here's how you always write down a condensed structural formula. You write a carbon, what's attached. Next carbon, what's attached. You never put bonds inside. So let's do it together. So on that first carbon, how many hydrogens do you see attached? Okay, so this thing, I'm just going to rewrite it as a condensed structural formula. So CH3. What's on the next carbon? CH2. So CH2. Then on the next carbon? Okay, so CO2. So that's your ester part. Then? Good. Right, you're onto this. So CH2. And then you keep on doing that until you get to the end of the chain. Yeah. You can put it in brackets if you want to. How many CH2s do you see there? There are 3 of them. Right, at the end there's a CH3. I know that's written really terribly, I'm sorry. So CH3, CH2, CO2, which is the indication that you've got an ester. Then CH2, all added up, there's 3 of them. So we've put those in brackets. The other time that you use brackets is if there's a branch. That's the other time that you can use things. Other questions?
So, can you not include the CH2 on the left in your bracket because
No, you can't, I'm afraid. It's in the order that they're joined. Because we still, so what Aaron's asking is, can I not include the CH2 on the left? So that is this one you're talking about, right? So can I not include that with these other CH2s when I'm doing this? And I can't, I'm afraid. Because I've actually got to give away an indication on how this is all joined together. I've got to put them in their orders. Okay. Any other questions about this? Everyone relatively happy? Ryan?
So, for on the in plots, if you took 2 of the H's away and put it over, then it would be at the end CH, the CO, CHO.
How do you mean?
Like, okay, so let's say we're doing the index formula and let's say it was C, because at the end there's the carbon can make bonds and
Yes.
it's got 2 bonds. So if you take 2 H's away and you replace the H's with an O, so that now the carbon would be
You would change your structure then, though as well. Yeah. It needs to be in the order that they're joined, the order that they're bonded.
So, like, let's say we had just
Okay, now in this example, I've given you unknown compound A, unknown compound B. I've combined them with a little bit of sulfuric acid, that's H2SO4. My organic molecule that I've made is methyl propanoate. I've also got an unknown product C. I would like to know what A, B, and C are. Now, what I recommend that you actually do is that you draw out methyl propanoate, because that will give you an indication on what the alcohol and the carboxylic acid were that went into this. Right, so this alcohol, the carboxylic acid that go into this, I need you to be able to predict this. I'm going to give you a few minutes to sort this out. We'll take some questions, and I think we'll call it quits for today after this. So the first thing I need to do is I need to draw out my product, and that'll give me some sort of clue as to what to do. Okay, so when I draw out methyl propanoate, you always start with the backbone and then you put all the other bits and pieces on. Okay, so how would I draw a propanoate if I was asked to? How many carbons? There's 3 carbons. So 1, 2, 3 carbon atoms. To make it an O8, there we go. Right, so that is a propanoate. Okay, so I've got hydrogens all the way around. This is propanoate. But now, I know that there is a methyl. How many carbons in a methyl? 1. That's not too tough. So there's my methyl attached to the oxygen on a propanoate. How do I know not to put the methyl directly on the carbons? I've written them separately inside the word, and that's how I tell. Okay, so there's my methyl propanoate. Let's chop it into 2 pieces. Okay, so I've chopped it into 2 pieces now. I'm ready to figure out what the pieces were that went into it. Okay, so let's give ourselves a little bit of space, and let's chop them into their various pieces. Okay, so the green part, if I was to change that slightly, what would I have? So propanoate becomes propanoic acid. It keeps a double bonded O, which means that it's not the alcohol here. This must be the carboxylic acid. So this is propanoic acid, which is probably one of the reactants that went in. So propanoic acid, really nice way to get propanoate. In fact, the only way. What about this single carbon chain over there? Where would that come from? That comes from the alcohol, and that comes from a 1-carbon alcohol, which is called methanol. So there we have it. We've got methanol. Now, I like to draw them facing each other because that shows me how they go together to give my ester. And this also gives me product C. So the OH from the acid and the H from the alcohol, they go away. And what is product C? Water, H2O. And for this reason, because you're making water, which is a condensate, you will very often find that these are called condensation reactions.